Hi physics students, Mr. Rick here, and today I'm going to be talking with you about two different ways that we can visualize motion, motion maps and distance versus time graphs. So the goal of this presentation today is going to be how can we visualize how an object's position changes with time. And as just a little refresher, remember that motion is when the position of an object changes with time. One way that we can visualize how an object's position changes with time is by using dots. These dots represent the motion of different objects. 1 second elapses between each dot. So which object has the fastest speed, which is the slowest, and how can you tell? Object B is the fastest of the three different objects. And we know this because it's covering the greatest distance between 0 seconds and 1 second compared to object C, which is the slowest, and you can see from the diagram that is covering the smallest distance from 0 seconds to 1 second. We can use the length of an arrow to represent how fast the speed is. So if we were to simply just draw in an arrow in between each dot, that length of the arrow is going to represent how fast it is. So if we take a look at our fastest object, object B, you can notice that the arrows are the largest, right? So it's covering the greatest amount of distance per second compared to our slowest object, and its arrows are the smallest because it's covering the least amount of distance per second. Another way to visualize the motion of an object is to use a graph. So we want to see how the object's position changes with time, so we move the motion map to the y-axis of the graph. So if we were to take its position at 0 seconds, right, so where it starts, that's going to be a distance of 0. And after each second, we can see that it is moving a particular distance. And so we just simply plot that point on the graph. So we just move that over and we can see, right? So at a distance of 1, its time is equal to 1. But now let's take a look at a faster object and see what that would look like on a graph. So now we have a faster object. So there's a greater distance in between each second. So if we were to put that on the same graph, we can see that it's moving farther after each second. So after 1 second, it's moved a farther distance, and after 2 seconds. And so the result of, if we were to put the faster moving object's motion map onto the same graph, we would notice that it has a larger slope, or the slope of this line is greater. Now we can take a look at a slower object. A slower object is going to move less distance per each second. And so when we put that onto our graph, we can see that the slope is less than our first object and our second object. So you can use the slope of a line to tell information about how fast an object is moving. The motion map and graph below both represent the motions of objects A and B. Which motion map corresponds to line number 1? And how do you know? Object A corresponds to line 1. And we know this because the arrows are shorter, meaning it is traveling at a slower speed. So we would expect whichever object is moving at the slowest speed to have the least or the smallest slope. And we can see that object B has larger arrows and there's a greater distance in between each time interval or dot, so we would expect that to have a greater slope. Also, A started further further forward compared to B. So if we think of this X scale right here as a distance, and if we were to set this end to 0 and the right end to 10 meters, we can see that object B is starting at the 0 meter mark and object A is starting a little bit further down. And if you compare that to the graph, you can also see that object B, which is represented by line 2, starts at the 0 mark for distance, and object A, which is represented by line number 1, starts a little further along.